All right, Keisuke. So I recently found out about this phenomenon called microchimerism, which was completely new to me. Now, when I think of chimera, I'm thinking of a Greek mythological beast.
Right.
Have you heard of this one?
Yeah. I forgot which part of the head, but the goat body and the serpent tail.
Yeah. And a lion
kind
head.
of like
Yeah.
I do see that kind of monster a lot in tons of video games.
Right.
Yeah.
That's right. Me too. From video games. So it's become a kind of a metaphor for what we see in biology,
Sure.
right? Of some kind of a body having mixed parts of different genetic origin.
Yeah.
Something like that, right? So now they've got this term microchimerism. Here's the main way that it happens. When the mother has a child, the mother's cells, the somatic cells, not just her germ cells, travel through the umbilical cord, through the placenta, through the umbilical cord, and the fetus receives the mother's cells.
Exactly.
And it also goes the other way.
Yeah. That's actually interesting part to me because it's sounds like reasonable for some cells moving from the mother to the child. Yeah, that kind of okay because like antibody or any nutrition can have to travel from the mother to the baby. Otherwise, baby cannot survive. But like backwards, like some cells can also move from the baby to the mother.
Yeah.
That's so interesting. Why does this happen? Also, okay, what is the effect on the mom?
There's been at least a few cases that it's demonstrated to have some effect.
Right.
So one of them is that bidirectionally, the cells from the other organism don't just stay in the bloodstream, but they actually colonize all over the body. That includes going into all sorts of immune cells.
Yes.
And maybe this has to do with the idea of not rejecting a foreign body.
Right.
If you're carrying this fetus, you want your body to accept it.
Exactly.
And maybe some of these immune cells that comes from the fetus is communicating with your other cells and saying like, hey, just leave that thing alone. Maybe. And you mentioned that through the placenta, the mother is also sending antibodies to the fetus.
Yeah.
Well, she's also apparently colonizing the fetus's immune cells with her own, I guess, like an education, I guess.
Yeah.
Does that seem like a practical use or for evolution to employ this method?
I just want to say that this happen also in other animal species, because the human, maybe primates as well, we do have a more close connection in the placenta. Between the mom and baby part. Like blood vessels are very closely intermingled. Just the boundary is very thin layer. But for instance, ruminant, like a cow or goats or sheep, they have more like a thick borders between mother blood vessels and baby blood vessels, so that they have to, their babies have to drink colostrum after birth.
Oh, yeah.
Otherwise, they cannot get antibody because the antibody cannot pass through the placenta from the mom to the baby.
That's really interesting. But no, it is discovered in ruminants.
Then if like the microchimerism can also be seen in ruminant or any other animals, so in that case, maybe that part, microchimerism might be contributing to the evolution of the mammals.
That seems to be the current hypothesis, that it's widespread. So you would think maybe, it must have some sort of evolutionary benefit, some sort of fitness benefit.
Yeah.
But evolution's never that easy, is it?
Yeah.
Because there's also these issues of a correlation between an increased amount of fetal cells in the mother and an increase in conditions like rheumatoid arthritis.
Autoimmune diseases. You mean?
Yeah, autoimmune diseases.
Okay.
Yes,
Yeah.
yes. There's another one, systemic sclerosis. It's also called scleroderma.
Okay. Yeah.
And this is where your skin
Right.
gets really, really tight, and you can't even move your fingers.
Yes, those diseases can be developed by autoimmune diseases, like your immune system just be too much activated, and then they're gonna attack your cell.
Yeah.
Yeah.
And then now we see that there's also, it's more likely to happen in mothers. And now we can see within the mother's group, those with higher proportions of fetal cells are more at risk. So there's a bit of a cost benefit analysis going on.